It looks like some of the questions are pretty hard. Yeah, I noticed that when I look at your solutions. Many different ways and very complicated. Yeah, but so we try our best to understand the structures of these questions better. Yeah. Sometime this weekend, I will post the answer file. Yeah. So you can, study. Also, in the final, you can also use answer file to questions. Yeah. Structure-wise, similar. Yeah. But I may change to different tables. Yeah. Same logic, but I will use different tables. Yeah. Otherwise, too easy. Yeah. So I need to make some change. Yeah. All right. So if some of the questions, if so let's look at the problems. Yeah. First, use max function. Yeah, there is one problem. Yeah. Max function, so here I want to explain that small difference. Yeah. Question number 9, list the first names, last names, birth dates, those employees. Here you can see could be more than one, right? Those employees. Yeah. So usually, based on the logic, it could be more than one employees who are the youngest in the company. Yeah. But if you do not use the max function in the right way, you may only get employee. That's sufficient. But here, we want those employees who satisfy the requirement. That's the difference. That's different. So let me show you two different solutions. Yeah. The first one, right, this one, we apply max function b date. Yeah, you can do that. It's legal. Yeah. If you do in this way, the answer is one row. Only have one row. It returns one row. Which one? I mean, just based on the natural order, the first one. Yeah. So when the DBMS execute the query, the first one that satisfies the condition, that selected and then stop. Yeah. Yeah. Way quite different from our requirement. So you need to be careful. Solution, I take 1 point off. Yeah. So we want to list all employees for the condition. Try to avoid this problem. For all, you can use this way. B date equals inner query. Yeah, you can inner query inside parentheses, and this inner query generates max number. The current employee satisfies this condition. B date equals that max number. All the employees that satisfy this condition, all selected. Yeah. So That's exactly what we want. Exactly what we want. All right. Yeah. So here, regarding this equal sign, you can use the equal sign in this way. Some students may feel, not comfortable in equal sign in this way. Yeah. Actually, this equal sign, the way to use in this way, it is related to the in operator. You know in operator, right? Yeah. In operator, if we put the one inner query, we do inner query, we get multiple rows, right? Yeah, multiple rows. Then some number in. Yeah, so from the logic, if you understand it from the logic, yeah, one number is in. But here, because this query only contains row. Yeah. So this because max function always returns one row. In the one row situation, if a query only returns one row, and in and the equal sign the same. Yeah. See? But is 1. If more is equal sign, but you can still use the in operator. Yeah. So that's this way. Yeah. All right. Yeah. Then question number 11. Yeah. So, yeah. Here we need to understand. Yeah. Controls maximum number. Yeah. So this time we need to use the temporary table. Yeah. All right. Yeah. Let's look at the, yeah. So here I want to point out another similar problem. Yeah. Because just the department numbers and the number of projects controlled by these two, such that department control maximum number of projects. The thing is, you may have multiple departments, right? Not just one, multiple. You only produce one department, if this way. Max, yeah, only one. Okay, so when you get a max, then you stop, just like the M max B there. Yeah, but to represent all such departments, we need to use our, the equal way. Yeah, so we can define temporary table. Is the equal operator. The number of projects go through all the departments. That max number. You have all those departments, not just one. No. Try to compare. We have one. First question, I didn't say, let's find. You only give me one row. requirement carefully. Way, oral way, all good. But if I question, I said, you know, okay, all right. Later we will look at question number 1. Yeah, because we have some other things to discuss. Yeah. All right, so that's this question. Oh, sorry, I need to go to the, question number 1. Yeah, but here, because from the question, first name of an employee, just one, okay, one is fine, We do not need to. Actually, for this situation, there is another popular way people may use, sort. Sort. So this solution process maximum number of products. And later we will talk about this a lot. How to represent number of products. Because the exact meaning, there are many different ways to understand. I explained the specific meaning. In my grading, I so many will compare them, different understanding of what's the number of products. So when we say number of products, we use the product ID to identify. Product 1 could be ordered multiple times. And each time there is certain quantity number. So then many students sometimes use the quantity representation, sometimes use the order representation. Maximum number. If one product multiple times, we only count once. In different orders, many times, we only count once. So that's why here, in our count function, we put this distinct keyword. All right. So then we join orders table, order details table, because we need information, So order, here, right, because so here, right, because in the orders table. In the orders table, because we need to use the employee ID to connect to employee table. Order details table do not have employee information, right? Think about it. In the order details table, there is no employee information. Connect order details table and the employee table. We need to use orders table to connect these two tables. So then by employee ID, number of products based on employee IDs. Yeah. Each employee ID, we define group. Yeah. There. This solution, this is one of the solutions. Yeah. Yeah. This solution, way some students give me top 3. Yeah. You know. Wait. Just, but I know the student, try to do something. Try to address that more than one. Try to address more than one problem. So give me top 3. Yeah. Yeah. But if we want to get all of them here, this solution. Let me see. Chat message. Oh yeah, chat message. Let me turn. Cutting. Oh, the microphone not good. Yeah. Probably I'm walking. Yeah. I try to stay here. Yeah. Oh yeah. When I walk around, probably not good. So I try to stay in the same place. Yeah. All right. Yeah. It has some problem. Yeah. Yeah. When I process my video, sometimes I heard, some microphone sound problem. Yeah. Probably when I walk, there is such problem. Earlier, why is that? Yeah. Fine now, but it was cutting out earlier. Yeah. So, because now I stand in one place, in front of my machine. Yeah. All right. Yeah. This is our last class. Let me just, make sure sound is good. Yeah. But in future, probably I'm thinking about get a better microphone. Yeah. All right. Yeah. In the second one, so we use a temporary table. In this temporary table, we want to get the, so I need to write it here. We need to get the, counting information. Yeah. Also, employee information. Yeah. Employee. Yeah. Actually, there is another way. Yeah. So this is one of the ways. Yeah. At the same time, we get employee information in the temporary table. Yeah. Another way is we can get employee information in our main query. Yeah. Temporary table, we only calculate the counting numbers. Yeah. Yeah. Different ways. Yeah. Yeah. So here we just retrieve the required information from the temporary table. Yeah. Yeah. All right. Then use this equal operator, so we get all those employees who satisfy this condition. Yeah. Although for this question it's not necessary, right? Yeah. But this answer is not wrong, right? Yeah. So I do not say it's wrong. Yeah. Okay. Yeah. All right. So that's this problem. Yeah. Next one, I want to explain this number of products, because many students, they use different ways to present the number of products. All right. Yeah. One student here use the quantity way. So here, okay, sum of the quantity. Look at that. Okay, yeah. Sum of the quantity. Yeah. That's one typical understanding. Yeah. Yeah. So when you read the question, you need to think about. So when we say one product, two products, three, yeah, what is the most straightforward understanding? Yeah. Products. Yeah. We do not say items of some products. Okay? Yeah. So, so you ask yourself, what is the most natural understanding? Okay? When we say products. Yeah. Understand the most straightforward understanding. Yeah. We identify products by their names, right? So product 1, name 1. Product 2, name 2. So product names equivalent to product IDs. Yeah. Things like that. Yeah. But not a quantity. Okay? Yeah. Quantity, so we need to use more description words to describe the quantity term. Yeah. All right. So that's one way. Another way. Yeah. So yeah, it's a little small. Another way. Look at like this. Order. Look at here. Count order ID. Yeah. Order counts. Yeah. So first table. Count the number of orders. All right. Yeah. Then take the maximum number of orders. Yeah. So here you can see this understanding. So that's a different product. Okay. One product can be ordered multiple times in different orders. Yeah. So here, counting the order numbers. Then the second table, maximum order numbers. So then that number equals the maximum. Yeah. So So here the main difference is how to understand the number of products correctly. Okay. Yeah. Yeah. So here So the way we want to have based on the product IDs. Yeah. Yeah. So here you can see it's very easy. People use the different understanding. Yeah. So if in the final, probably, in order to avoid a misunderstanding in the final, I may put in the parenthesis. Yeah. Yeah. If some term is confusing, so then I give you the explicit explanation inside parentheses. Yeah. What I mean, number of products, my meaning is you count based on the different product IDs. Yeah. Not the orders, not the quantities. Yeah. Yeah. So I try to, in the final, I try to put more explanations in the questions. Yeah. 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 Because I want to make sure you understand correctly. Okay. Yeah. Yeah. Otherwise, for a question like this, yeah. Yeah. The way you write the query is correct. Yeah. But the only difference is you didn't use the correct understanding of the concept. Yeah. All right. So in final, we try to avoid this problem. Yeah. This question, two different, yeah, because when you read the question, yeah. So in the final, I want to make the point. try to read the question carefully. Try to understand the question completely. Yeah. So read it a few times. Okay. Yeah. For this question, there are two concepts here. Yeah. In my hints, I describe that. Yeah. I believe quite some students, they didn't study the hints. Yeah. Quite some students. Yeah. In my grading, I can see it. Yeah. Otherwise, so they won't make this kind of mistake. Yeah. Because here, we have two different concepts we need to count in one question. But people tend to understand in one question, we only count one type of objects, not two types of objects, only one type here. So here, first type, number of products, that's one type, right? Yeah, products. So your object type, product type. Then the second object type, items of the products. That's a different type of objects, right? Yeah. Product items, different. Yeah. Because one product, customers may order many items, right? Many items. Yeah. So we all count. Yeah. Large number of items, we all count. Yeah. Yeah. So here, separate these two different types of that. But when I look at your solutions, many students only use one type of objects. Okay? Yeah. So, yeah. All right. So let me show you the, yeah. So here, in this solution, yeah, in my solution, you can see for two different types of, so I do the aggregate functions two different ways. See? The first one, we count the number of different products. Yeah. The second way, we take the total. We calculate the total of all the quantity numbers, number of items. Yeah. Because these two aggregate functions we apply on the same subgroup, right? Yeah, group by, because the two aggregate functions. Yeah, although some students may separate. Yeah, first temporary table, calculate the first the count function. Second aggregate table, calculate the sum function. Yeah, yeah, it's okay, it's correct. Yeah, but because if the group by clause the same in these two temporary tables, the same, so you can combine, right? You can simplify it. Yeah. Same definitions for the subgroups. Yeah, you can combine. Yeah, okay. Yeah. So then the main query. Yeah. So you just use those two numbers. Yeah. Okay. Yeah. The count number equals the maximum number. Yeah. Okay. Yeah. Yeah. The maximum. Oh, sorry. Sorry. Yeah. The count. That's the product count number. Yeah. Because the have. Oh, sorry. Oh, just a minute. Oh, so I have some problem. Yeah, items. Yeah, because I use this items to separate. All right, items, product, items. Yeah, so here I use when you see the items, we use the quantity. Okay, when you see the items, we use the quantity. Yeah, the product number here, we do not have the item, right? Number of products, no item. Yeah. Yeah. That's the difference. Yeah. Okay. Yeah. So the maximum. Yeah. But the output, this side, we output the number of products. Yeah. Not necessarily output number of product items, right? Yeah. So here the difference. in our main query, this number not necessary this number. Yeah. Could be different. Yeah. Could be different. Yeah. 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 But I saw quite some students, same number. Yeah. Yeah. So when you read the question, be careful. Yeah. Yeah. You need to calculate two different objects. Yeah. All right. Yeah. So here I want to show you, another solution. Here you can see the student used the quantity number, right? Yeah, quantity number, but no product counting, right? Different products. Yeah. Where is the? So here you can see the output. See the output. The quantity, total number of sum of the quantities. But our output, the output is the corresponding number of products. Okay? Yeah. Product by their names or IDs. Yeah. That count. Yeah. But not the number of total items. Yeah. So here you can see it's very easy to get confused. Yeah. All right. Another solution. Okay. So the quantity, the sum quantity, right? Yeah. Maximum. Yeah. Look at the max sold, also quantity, right? Yeah. Also quantity. Yeah. Yeah. But missed this number of products. Yeah. Okay. So read the question carefully. Okay. Yeah. In the final. Definitely in the final, we will have a similar question, okay? Similar to this one. Yeah. Two different objects, you need to apply aggregate functions. Yeah. But I will use different tables, okay? Yeah. I will, the structure exactly like this one, but I need to use different tables. Yeah. So it's a new question. But you need to learn from this question. Okay? When you apply aggregate functions, you need to use two different aggregate functions. Here, the same aggregate function, only some aggregate function. Yeah. No count function. Yeah. Okay. Yeah. All right. Represent the same location. Yeah. Another concept. Look, we have a question number 13. Yeah, so this is another question. We need to find the right way to represent. All right. Last name, first name, employee, such that all the projects worked by this employee are at the same location. Yeah. Yeah. All right. Yeah. Same location. Yeah. So I noticed there are different ways to represent same location. How do we represent same location? Yeah, yeah. One simple way to represent, you count the number of locations, then that count number is 1. That's the same location, right? Yeah. So the most straightforward representation, you calculate the location counting number. Distinct, yeah, because some maybe different projects could be in the same location, right? Yeah, so distinct. When you count, same location may appear multiple times, but you only count once. Yeah. After you make distinct, you count it, then it's 1. Then the count number is 1. That's the same location. Yeah. All right. Here you can see, count number, So we can use an inner query, but some students use a temporary table to define this inner query. It's okay. The logic is the same. Yeah. Yeah. So here, because our inner query, it is a number, right? It generates one count number. So that count number equals 1, same location. Okay? Yeah. All right. Yeah. 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 All right. Yeah. Projects, works on. Yeah, same. Oh, just a minute. Here, I didn't talk about, oh, this may be a little different. I didn't, because I didn't talk about location, right? Oh, yeah, I need to double check. Because the location, we have to target the location directly, okay, not indirectly. So, yeah, yeah. I may get it wrong, so I will double check this one. Okay, I will double check this one. Yeah, because we need to target the location directly, right? Distinct P location. Yeah, I like this way, because we need to target the location directly. Yeah, so that's why there is some problem. I need to modify it. Yeah, yeah, yeah. So this way, define temporary table. Okay, then, we use the temporary table, inner query equals 1. Yeah, that's the correct way. Yeah, yeah, count the location. Yeah, all right. Yeah, so here, join project. Yes, join project. Yeah, right. Yeah. All right. So yeah. Yeah, I will modify this one. Yeah, because we need to target the location directly. Yeah, yeah, not indirectly. Yeah, indirectly, most of the time it could be wrong. Yeah, yeah. So we do not trust indirect way. Yeah. All right. Yeah. So that's one. Yeah. So I found a problem. Yeah. Yeah. So after I update my answers. Yeah, I will post my answer files. Yeah. All right. This one worked by employer. Yeah, yeah. Here I want to give you a different way. Yeah. So this is another because here I want to talk about the representation of the location. Yeah. So this another. Here you can see the representation is very complicated. So it's correct or not, it's another question. But the first thing is the logic is very complicated. Okay? Yeah. Second, we need to check if it's correct. And the readability. Yeah, there is a readability issue. Yeah. Even if it's correct, there is a readability issue. Yeah. All right. So here you can see works on. There are 2 copies. Using works on table, okay? Yeah. The first works on alias W1, second works on W2. 2 copies of the works on table. Then 2 copies of project table, P1, P2. Yeah. All right? So connect these 4 tables. Yeah. Yeah. All right. So then the condition, how to represent same location. How to represent same location. Yeah. P1 location and the P2 location different. Yeah. When different, then that's the logic. 2 location, if different, yeah. If because condition is employee, yeah, same employee, right? Same employee. Yeah. So here you can see the logic, is quite there. It's quite there. Yeah, yeah. If you want to follow, you need to dig very deep. Yeah, you need to draw a diagram. Dig very deep and see. Yeah. 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 But even if it's correct. So there is a readability issue. Okay? Yeah. So readability is not good. Yeah. Yeah. Very hard to understand. Yeah. Okay? Yeah. Yeah. So try to use a simple way to query statement. Yeah. One example. Yeah. Yeah. All right. Present total amounts of money. Yeah. So in my hints, I give you a way. Well, but in my grading, I saw many students didn't use that way to represent. Yeah. Yeah. So use some very messy way. use some way, yeah, but quite messy. Yeah. Yeah. Here, I understand that these questions relatively hard. Yeah. Because first, we target complex queries, right? Yeah. So our homework assignment number 3, we target complex queries. First 2, we target simple queries. Yeah. But the last one, we need to practice. We need to get experience on complex queries. Yeah. Some queries, but you need to go through this, hard work, learning experience. Yeah, you need to have that. Yeah, yeah, yeah. All right. So, and here, with their total amounts of money. Here we need to represent total amounts of money for the products ordered. Yeah. Here you need to consider the items, right? Yeah, because each item, there is certain money associated with it. Yeah. So you need to calculate, take the sum of, items, multiply the price, yeah, corresponding price, yeah. But for different products, yeah, all ordered by one customer. Yeah. This time, not employee, customer. Yeah. Customer, employee, 2 different concepts. Not confused. Yeah. Customer, employee. Yeah. Yeah. Customer make orders. Employee process those orders. So that's different. Because one employee can process multiple customers, right? When you do the counting calculation, yeah, so based on employees, based on customers, different. Yeah. All right, so here, total amounts of money, product ordered, but here based on the customers. Not employees. So you do not need to mention any employee. Okay? Ordered the maximum number of products. Here, 2 different objects, right? The first amount of money. Money as the first type of object. Second, total number, maximum number of products. Product, different type of objects. Products. Yeah. Yeah. All right. Yeah. Here, first temporary table, you calculate the money, the calculation, quantity times the price. Order details table. Because for each order, there are several rows for each order. Because for each order, multiple products could be ordered, right? Yeah. So here we may draw a table like this. Okay. All right. Table. Yeah. Then, because there are multiple rows, yeah, let's say, so this is order order 1. Okay, order 1, there are product 1, product 2, product 3, right? Yeah. Different products. Product 1 has the number, the quantity 1, right? Yeah. Yeah. So let me use the product 1. Quantity 1. Product 2, quantity 2. Product 3, quantity 3. Okay? All right. But product 1 has the price 1, right? Yeah. Product 1 has the price 1. Product 2 has the price 2. Product 3 has the price 3. Okay? All right. This price we can use, we join the products table. Yeah, after the join, we can get this price information. Okay, all right. Then we can calculate the money amount multiplication. So for each product, how much money? You can calculate quantity times the price. Yeah. Same price, yeah. But one student messed up. As for different products, the price is different. Yeah. Yeah. Some up all the quantity numbers for different products. They have different. Add up which price you want to use. Right? What price number you want to use. Yeah. So you need to calculate the amount number separately. Yeah. Here we do separate calculation. So this temporary table, we do the separate calculation. Yeah. All right. And another temporary table, this time we calculate the number of different products. Okay? Yeah. Although these two temporary tables, the group by clause, the same customer, but it would not be good to combine these temporary tables. Yeah, because table we only join two tables. Yeah. So if you want to combine, if we want to combine, we can make it. Yeah, because for readability, if you feel very messy, because it's very hard to understand, then you separate. Okay? Yeah. Later, yeah. So usually for the situation like this, our first version may not be the perfect version, right? Yeah, it's very common. Our first version is not a perfect version. Yeah, this is our first version. Yeah, but our later versions, when we understand the question, the problem, the solution better and better, later when we improve, after we understand it much better, we have confidence. Then we can merge and simplify. Yeah. So our later versions, we can do better. Yeah. But first version, we just want to make sure it's correct. That it's not too bad. Yeah. First version, if it's too bad, you have to improve it. This version is not too bad, right? Yeah. It may not be the best, because there's a chance to merge these temporary tables. Yeah. But the problem, so why we do not merge, the problem is it makes the understanding a little harder. Yeah, that's the only problem. Yeah, a little harder. Yeah. All right. So that's That's my definition of two temporary tables. This is the main query. Yeah. Too long, so I split into two slides. In this main query, so we join three tables. Yeah, three tables. Yeah, two temporary table and a customer table. Okay. After the join operation, then we calculate the maximum number of products. Yeah, yeah, yeah. The condition. Yeah, but people tend to count the maximum amount of money. Yeah, yeah, yeah. All right. Yeah. So here I show you a different solution. Yeah, different solution. Yeah. Here you can see. Yeah. So you can see amount of money is calculated. Yeah. Amount of. Yeah. But also the second one calculate the quantity. Sum of quantities that's different from. Yeah. We count the number of products. One product. Still the understanding. Yeah, still the the concept understanding thing here. Yeah. All right. Yeah. Another thing is here you can see table join. Yeah. This is the table join part. Yeah. All right. Yeah. Then having clause. Yeah. Having clause. Okay. All right. Yeah. Yeah. To understand, so we need to dig into the structure. First, we need to draw a diagram to understand the table join part. Yeah. Then the condition we need to check the having clause, the condition. Yeah, yeah. Yeah. So usually, for very time consuming. Yeah, very time consuming. Yeah. Yeah, another solution here, yeah, number of quantities. So one temporary table, the maximum. So here you can see in this answer, there. So, yeah, this is half. Yeah, half. Okay. Yeah, this is another question. Yeah, another question. Let's look at how to calculate. This part is the calculating amount of money, the part. Yeah. But this part, look at the formula. Here. All right? Yeah. Number of when you count the quantity across different products, quantity, okay? You calculate the maximum, yeah, all right, yeah. Then when you calculate the money, that max customer, this one, if it's the one product, it's okay. If you group by product ID, yeah, it may not be wrong, yeah. So that's good, because here you do group by product ID, okay? Yeah. So you calculate the total quantity by, yeah, so, yeah. The logic is correct, yeah. The logic is correct because you calculate. So then you calculate the amount of money, yeah. So This way is correct. Yeah. Although just a minute. This understanding is slightly different from our question. Because when we calculate total amount of money, we don't need to use the maximum, right? Yeah. Total money calculate. Why do you use the maximum? Oh, maximum. Let me see. Oh, so we find a maximum. Oh, okay. We only calculate. Oh, okay. That logic I understand. Here, this student calculate maximum number of products. Yeah. Quantity. C calculate the number of products based on not based on the product ID, based on sum of quantities. How to specify the maximum number of products? Yeah, based on this. This is the way for the maximum number of products. Yeah, so that's the understanding. This place issue here. Yeah. If our understanding is based on product ID, this is a different understanding. So this calculates the number of items for the same product. That's the only difference. Yeah. Log is okay. Yeah. All right. Yeah. Very important. Yeah. Represent all property. Yeah, because here we have this. All the customers processed by this employee have used the shipper, given shipper. Yeah. But how do you represent all? Yeah. All. Yeah. We have one example in our notes. Yeah. Negation, way, yeah. 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 So here, yeah. Not exists. Yeah. Not exists. Yeah. Set A and set B. Yeah. So here we represent set A and set B. Yeah. Yeah. This is a set A. Set A, yeah, the customer, yeah, yeah, from order, customer, employee, yeah, the current employee, yeah, all right. So all the customers processed by current employee, yeah, that's set A, yeah, all the customers, yeah. Then set B, this is set B, all right. All the customers who use the given shipper. Okay? Yeah? So customer, they need to use. That part not hard. Okay? Set A, set B, not hard. Then you need to. So the all thing is you need to represent A minus B is empty. Yeah. This minus is the set minus. Yeah. So it's not a arithmetic minus. Set. Except. That's the same thing as the except. Remove. Yeah. So this set is empty that not exists. So you use in and not in to represent this set. In, not in to represent this set. Yeah. So A is contained in B. Set A is contained in set B. Yeah. So that's the same structure we use in our class. The example in our notes. Set A is contained in set B. So we use this way to represent. Okay, yeah. All right. Yeah. Yeah. Not complete. You understand example in class. Yeah. Yeah. Then, when you represent set A, use one query, inner query to represent it. That's not hard. Second, you need to represent this structure. Yeah. 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 But many students use different way. Yeah. So they didn't follow our given example. Then it's too hard. Yeah. Then the representation, you can see a lot of problems in the representation. Yeah. So let me give you one example here. Yeah. Here you can see the main part. Look at this minus. This minus is the arithmetic minus. This is not a set minus. This query select total order. That's a number, right? You get a number. You select another number. Okay. You take difference equals 0. Yeah. Yeah. Because we want to between two sets using the numbers to So two sets. So here, this condition, two sets have the same. So for two different temporary tables. Yeah, two different sets. Yeah, set A, set B. Yeah. So two sets have the same number of elements. Yeah, this condition tells us. So here I can write set A, set B. Okay. Suppose this is the set A. Yeah. But set A, set B representation also, because count the order ID. Yeah. By employee. See? Yeah. Oh, yes. Yeah. Yeah. Here, employee. Right. Set B. Yeah. All right. Then compare the elements. This is this comparison condition. You compare the number of elements in two sets. So the element A equals the element in set B. So here. Yeah. Vertical bar. So we call the cardinality. Cardinality of A equals cardinality of B, right? Yeah. So you use this condition. This condition is different from. Yeah. Although these two sets have the same number of elements, but they could be different, right? Yeah. Yeah. The content in these two sets could be different. The content could be different. Okay? Yeah. Only the aggregate functions are the same. Yeah, because the cardinality, that's the aggregate information. Yeah. That's the same. But you cannot say these two sets are the same. Yeah, actually, what we need is the all customer process by this employee have used the shipper. Yeah. So set A is a subset of set B. Yeah. Because the shipper can provide services for more other customers. So the customers processed by this particular employee, only part of all the customers who use this employee. So, yeah, so that's what we need. Yeah, but this representation, you can see, far away from what we need. Here the number of the example in our we learned in our notes, the previous one. Yeah, this one. Yeah. Here you can see if you use this way, yeah, not too hard. Yeah. But if you do not this way, yeah. So you try very hard, miss a lot of things, right? Yeah. So yeah. But yeah. All right. Yeah. So I can only have time for last question. Yeah. Number 15. Retrieve first name and last name each employee. Work on all the projects controlled by one of those departments. So maximum number of. So here I modify our example in class. Our example in class is the Department 5. Department 5. That's old example. And here, but I said, one of the departments that control the maximum number of projects. So you need to use the template table to calculate it. Calculate all those departments that control maximum number of projects. Calculation is easy, right? Yeah, for us, that's a simple query. That's easy. Yeah. So we count first department. We count each department. We count number of projects, okay, controlled by this department. Okay, yeah. Then we can calculate a second temporary table. We calculate the maximum number of projects. So all the second temporary table gives us all the departments that control maximum number of projects. So ready to use in the main query. Main query, we needed the second temporary table. Okay. First temporary table, calculate the second temporary table. Okay, yeah. Now, in our main query, main query here, all how to do that all, we still use set A, set B, right? Yeah. So this is set A. Oh, yeah. So I need to complete quickly. Yeah. Set A except B. Yeah. So this way also okay. Two ways, fine. Set A, set B not exists, but this time we need to address the maximum. Multiple departments. All possibilities, we do the cross product, right? Yeah. This join, because there is no join condition, so it's a cross product join. Yeah. All possibilities. We try, we test it. All the possible join. Okay? Yeah. Then condition. The one that passed the test. The one passed this test. Yeah. Straightforward. Yeah. So here, this last question. Yeah. If you understand our given example in class well, Department 5, controlled by Department 5. Yeah, so not too hard. And this one. Yeah. Otherwise, it could be very hard. Yeah, it could be very hard. All right, let me stop right here. Yeah, so I will keep up.